Proving lines parallel. What does it take to prove that lines are parallel if we don't know that they are? What are some relationships that we've already learned when we know that lines are parallel? We're going to be using those relationships. Okay, the first postulate says if two lines are cut by a transversal, again, we don't know if these lines are parallel yet, but if they are cut by a transversal so that corresponding angles are congruent, then we know the lines are parallel. So if corresponding angles are congruent, the lines are parallel. So we write it like this. If corresponding angles are congruent, then the lines are parallel. We use abbreviations and symbols to make it a lot easier to write out these postulates. So if we see a situation like so, where we have two corresponding angles, they show us that those angles are congruent either by congruency marks or by having the same measure, then we can say now that these two lines are parallel. We cannot assume that. We have to know that the corresponding angles are congruent, or other relationships that we have learned. For example, if we know that the alternate exterior angles are congruent, then we can say that the lines are parallel. So if we have something like this, here's our alternate exterior angles marked with congruency marks, then we can say that these two lines are parallel. Unless we see something that tells us those angles are congruent, we do not know for sure if those lines are parallel, and we don't want to make that assumption. If consecutive interior angles are supplementary. What is supplementary? Do you remember what that word means? That's a vocab word you need to know. It means they add up to how much? 180 degrees. Then the lines are parallel. So if we had something like this, maybe not, cut by transversal, and we had, say, 135, oh, my pen does not want to work half the time, 135 here, and then we had 45 here. Okay, we have consecutive interior angles. They add up to 180, 135 plus 45, and that's a 3, equals 180. Then yes, they are supplementary, so yes, we can say that these lines are parallel. Remember, we put arrows on those lines to indicate that they're parallel to each other. And then if our alternate interior angles are congruent, then we know that the lines are parallel as well. So here's our alternate interior angles. So any of the theorems that we've learned before concerning alternate exterior angles, consecutive interior angles, alternate interior angles, all those angle pairs, if those relationships are as we learn them, then we can assume that the two lines are parallel. Okay, if two lines are perpendicular to the same line, then they are also parallel. So a new way to determine if lines are parallel, we have line M and line P. P is perpendicular to line M. P is also perpendicular to line N. Because P is perpendicular to two different lines, then we can say these two lines are parallel if they're in the same plane. Okay, so this really should be two coplanar lines right here. Okay, they have to be on the same plane in order to be parallel, because they could be skew if they're not on the same plane. Through a point outside a line, there's exactly one line parallel to the given line. Okay, what the heck does that mean? Take it one little phrase at a time. through a point outside a line. Okay, so I would draw that like so. Here's a point outside a line. What this postulate is saying is that there is only one line. Exactly one means only one. Only one line that I could draw through this point that is also parallel to this line. So if I drew this line, say, through that point, is it parallel? No. Okay. I should erase it all. If I draw this line through that point, is it parallel? No. There is only one way I can draw a line through that point and it be parallel to the existing line. That is what that postulate is saying. There's only one way to do it. Like so. Okay, a postulate that goes along with that says that through a point outside a line, so again, I have a point outside a line, there is exactly or only one line perpendicular to, that should be two, the given line. Okay, so again, I can draw a line through that point, but is this line perpendicular to the existing line? No. I could draw another line through there. Is that perpendicular to the existing line? No. How many lines can I draw through that point that's straight down? Remember, this point actually has no size. Yeah, it looks kind of big there, so you might argue, well, yeah, you can draw a couple of lines in there. But the point has no size, so we really can't draw more than one line through that point, so that it would look something like this. Another theorem. Two lines parallel to a third line are parallel to each other. Okay, so here's a line, and here's a line parallel to that first line. Let's call this line L and line M. If I bring in a third line and say that it is parallel to line L, M is parallel to line L, are M and N parallel to each other? According to this theorem, yes. They are all parallel to each other. Again, this is all in the same plane, or like on the same piece of paper, or like on your computer screen. Okay, so let's use some of these relationships. Identify the parallel lines. Okay, determine which lines, if any, are parallel. So we have three lines A, B, C here, and we have a transversal PQ or QR or PR. So we have to look at these relationships here and see if anything's congruent or supplementary. If this is 77 degrees, then it's, here we go, vertical angle here would also be 77 degrees. Got to write quick with this thing. Okay. We know that. Without knowing that these lines are parallel, we know that vertical angles will always be the same. So now our question is, are these two same side interior or consecutive interior supplementary? Because they have to be in order for those lines to be parallel. So we just need to add them up and see if they equal 180 degrees. Yes, they do. So we know that line A is parallel to line B. Now we need to check out B and C, because if B is parallel to C, then A would be parallel to C, right? So we've got this pair of consecutive interior angles. If we add those together, are they supplementary? No. So these two lines are not parallel. If B is not parallel to C, then A is not parallel to C. The only two lines that are parallel are lines A and B. Find X and angle ZYN. Where is angle ZYN? ZYN. That's this angle right here, labeled 7x plus 35. So that PQ is parallel to MN. So again, we don't know that they're parallel yet. We want to know what values would make them parallel. So I need to find X. Remember, in the last section, I told you that when you're looking for X, looking for Y, find the two phrases that have the same letter in them and figure out what relationship they have to each other. So I'm going to look at these two angles because they both have an X in their marking. What name would we give this angle pair, if any? Is there a name for this angle pair? Well, they're on opposite sides of this transversal. This one's on the left, this one's on the right. And they're both outside of these parallel lines. They're not in here, they're on the exterior. So we would call them alternate exterior angles. And if these two lines are parallel, those alternate exterior angles are congruent to each other. And what do we do to congruent parts? We set them equal to each other. Now I'm going to just do the algebra, get my x's on the same side here. Let's cancel. Then I put my numbers on the same side. Solve for x. Okay, so that's the first part of my question. The second part says to find ZYN. So I need to plug this back in to the 7x plus 35. So we'll do it over here. And I do need my little calculator. What is 7 times 15? Well, that's 35, so 105 plus 35 would be 140. That's reasonable. That's an obtuse angle. Again, we don't ever assume anything from the way it looks. Okay, so we solved for x, and then we plugged it back in to find our unknown angle. So you need to be able to use these relationships to solve algebraic equations to find unknown parts. That's what geometry is all about, problem solving. All right, in this one, we know that x and y are parallel. And we know that angle 8, let's mark this, angle 8 is congruent to angle 16. Can you use the corresponding angle postulate to prove that A is congruent to B? So I know is parallel. I know that x and y are parallel. I'm trying to find out if A and B are parallel. But I can only do that using the corresponding angles postulate. So let's see if we can do that. If x and y are parallel, then angle 16 and angle 11 are going to be congruent. Angle 11 and angle 8 are congruent, therefore A and B must be parallel. So yes, I can prove that line A and line B are parallel to each other using corresponding angle postulate. 16 and 11 are corresponding and they are congruent because we know x and y are parallel. If 16 is congruent to 11 and 16 is congruent to 8, then 8 must be congruent to 11, proving that lines A and B are parallel. So the answer is yes. Okay, all the different ways to prove that two lines are parallel then. Let's go through that again. Show that a pair of congruent angle or corresponding angles are congruent. So we take any of our angle pairs, and if we can show that they have specific relationship, then we know the lines are parallel. Show that alternate interior angles are congruent. Show that alternate exterior angles are congruent. Show that a pair of consecutive interior angles are supplementary. If you're in a plane, show that both lines are perpendicular to a third line. And the last one is to show that both lines are parallel to a third line, also in a plane. So 6 ways that we can prove lines are parallel to each other. Know them, be able to use them.